Hi everyone. So in this video, we're going to wrap up our discussion of lines and linear functions by talking about a new way to write down the equation of a line. So far, we have been writing equations of lines in what is sometimes called slope-intercept form. So why is it called slope-intercept form? Well, when you have f of x is equal to mx plus b, or y is equal to mx plus b, what is the information that you need in order to write that equation? Well, you need the slope and you need the y-intercept. So that's why it's called slope-intercept form. And sometimes it's also called function notation, because really, and we'll see this in this video, that the other form we're going to learn for writing an equation of a line, it's not in function notation. So if you want to express a equation of a line as f of x is equal to something, then that kind of forces you to put it into this format of f of x is equal to mx plus b. So as I just said, this kind of format for writing the equation of a line really only works if you know the slope and the y-intercept. So this form works if you know both the slope and the y-intercept, or if you can easily find the y-intercept. But there's another form of writing equations of lines that is going to be really useful if you are not given the y-intercept. So sometimes you'll be given a point other than the y-intercept, and the easiest way to write the equation of a line is in what's called point-slope form. And so this, by the way, is not really covered in section 2.5 in your book, because 2.5 is focusing on writing things in function notation. But the reason I'm going over it is that it's really, really important when you get to calculus. In calculus 1, you're going to find basically you have to write the equations of things called tangent lines, and you're going to have a much easier time writing equations of tangent lines if you're comfortable with point-slope form. So basically, let me just kind of summarize what I said a moment ago, which is that there is another form for writing the equation of a line. And that's what's called point slope form. And I'll tell you what point slope form looks like in just a second, but let me just kind of tell you why it's useful. So this form is useful if you are given the slope and a point that is not the y-intercept. Or if you're given just 2 points. So we'll see kind of both examples. If you're given just 2 points that lie in a line and one of them is not the y-intercept, we'll see that you can also use this form. Okay, so what does point slope form actually look like? So basically, if you have a line, so if a line has a slope of m and passes through the point, so the point is we're going to call it x1 comma y1, its equation is, So what you do to write down the equation is you do y minus the y coordinate of the point that you know the line passes through is equal to the slope, m, times x minus the x coordinate that you know that the line passes through. So I think this will become clearer once we do some examples, but I just want to point out the fact that, I think the main thing that students might get a little mixed up in here mixed up with this form is, there's like a y and a y1 and an x and an x1. The important thing is that the y and the x, those are going to stay in the equation, right? Whenever you have an equation for a graph, it has to have a y and an x in it, or like an f of x and an x. It can't just be a bunch of numbers. And so the y and the x, those are going to stay. Those are permanent. You're not like plugging something in. Those are just a y and an x. The place where you're actually plugging in numbers is y1, x1, and m. So all of those are going to be numbers, whereas y and x are going to just stay. Those are going to be variables in your equation. So by the way, like, why does this work? Why is this a good way to write an equation of a line? And I think if you can follow this, this explanation I'm about to give, it will also kind of help you remember point slope form. So why does this work? Why would this be the equation for a line? Well, let's take this equation. So we have y minus y1 is equal to m times x minus x1. And let's divide both sides by x minus x1. So what happens if we divide both sides by x minus x1? We get y minus y1 over x minus x1 is equal to m. So what does that kind of remind you of? Well, the way that you find the slope between 2 points is you find the change in the y coordinates divided by the change in the x coordinates. So this makes sense, right? This is basically saying if you calculate the slope between any point xy and this specific point x1, y1, you're going to get m, which is the slope. So if you're ever trying to remember what point slope form looks like, if you start with this equation and just multiply both sides by x minus x1, that will lead you right back to point slope form. So I just wanted to kind of make a note of that. Okay, so let's do some examples. So first example I want to do is one where we're given the slope and we're given a point. So we want to find the equation of the line with a slope of 1/2, and we want this line to pass through the point 1, -3. And actually, let me color code this to match up with what we had before, just to make things a little clearer. What did I use here? I used green and purple. Okay, so this is green, so this was 1 and -3. Okay, so how does this work? Well, we just put this into what we saw earlier was point slope form. So we're going to do y minus the y coordinate. So the y coordinate in this case is -3. So it's going to become a plus. Is equal to the slope times x minus the x coordinate, so x minus 1. So we can simplify this a little bit and we would get y plus 3 is equal to 1/2 times x minus 1. So this would be the equation of the line in point slope form. Now, point slope form is fine, right? This is an equation of a line. So basically, what does it mean for something to be an equation that kind of matches up with a graph? It basically means that anytime you plug in a point that lies on your graph, it will satisfy this equation. So I guess what I'm getting at here is that it's okay that this is not in the form, y is equal to blah, blah, blah. It's kind of like when we had the equation of a circle, right? The equation of a circle, the x and the y are on the same side, actually. So like equations can be formatted in all different ways. And this is just fine as an equation of a line. However, there might be a case where you actually want to write this in function notation. So you can do that. You can first write it in point slope form like we did, and then you can actually translate this into function notation, and it's not too hard. So let's rewrite this equation in function notation, or you could call it slope-intercept form. So how would we do that? Well, basically all we need to do is take the equation that we have here and solve it for y. Because once you have y is equal to something, then you can rewrite it as f of x is equal to, whatever. So how do we solve this for y? Well, let's actually start by distributing on the right side. So that we can get this into basically f of x is equal to mx plus b form. So if we distribute on the right side, we get 1/2 x minus 1/2. And so now we can subtract 3 from both sides, and then once we simplify, we'll be able to rewrite it in function notation. So we'll have 1/2 x minus 1/2 minus 3. So in order to combine these two numbers, we want to make a common denominator. So we can write -3 as -6/2. And so now we can combine all of these and we get y is equal to 1/2 x minus 7/2. And finally, if we want to put this into function notation, that is going to be f of x is equal to 1/2 x minus 7/2. And so now if we wanted to know what the y-intercept is, now we know that it's -7/2. But we didn't need to know it in order to write the equation. It just kind of came out in the process of writing the equation. So yeah, so all we did in this case, we knew the slope, we knew the point, we wrote it in point slope form. And then to put it into function notation, we basically just moved everything onto one side, simplified stuff, and then rewrote it as f of x is equal to. Okay, so next example we're going to do is going to be it's going to have kind of like one extra step that we have to do. So in this problem, we want to write the equation of the line that passes through. And so this time we're not going to be given the slope. We're just going to be given 2 points. So our 2 points are going to be 5, 0, and 6, -2. Okay, so in order to use point slope form, we do need to know the slope, right? And so how can we find the slope if we're not given it? Well, we are given 2 points, right? And so we know that we're able to find the slope from 2 points. And so the slope is going to be equal to the change in the y coordinates divided by the change in the x coordinates. So remember, you can do that in kind of either order. So we can do either point minus the other one. So maybe let's do the second point minus the first one. So we're going to do -2 minus 0 as our numerator. And then that means that the denominator will be 6 minus 5. And so that comes out to be -2 over 1, which is -2. So that tells us our slope is -2. And now for the point, we have 2 choices, right? We have 2 different options for what that point is going to be. So we're going to actually do it with both and show that you get the same result either way. Let's start by doing it with the point 5, 0, because that's like, I think the slightly kind of easier point to work with. And then we'll do it with the other point, and we'll see that actually they simplify, even though they initially look different, we'll see that they simplify to the same thing when we put them into function notation. Okay, so what is our equation going to look like? Well, we know that we're going to do y minus the y coordinate of our point, so that's y minus 0, is equal to the slope, which was -2, times x minus the x coordinate, which was 5. So we can simplify this to just y is equal to negative 2x. Actually, let me leave it like this first so that this is in point slope form, because I want to show you how these are going to initially our point slope forms are going to look different, but then when we actually go and change them into function notation, that they'll look the same. So this was kind of version 1. So version 1 of the equation of the line in point slope form is this. Let's see what would happen if instead of using this point, we used the other point. So let's see what would happen if we instead use the point. So our other point that we were given was 6, negative 2. Let's see what happens if we use that point. So if we use the point 6, negative 2, we would get y minus negative 2 is equal to the slope. So the slope is still the same. The slope is still negative 2. And then we would have x minus 6. So let's just clean this up a little bit. We would get y plus 2 is equal to negative 2 times x minus 6. So you might look at these two equations and think these are completely different lines, but these are actually the same line. So even at this point, if you went and typed both of these equations into Desmos, you would get the exact same graph. They would look identical. They are the same line. And really, there's lots of different ways. When you're using point slope form, there's always going to be many different ways that you could write the line, because every line goes through many points, right? Infinitely many points. So really any point on the line will work in point slope form. And so when you're given two different points like this, you have a choice to which one you're going to use. Usually I would just use whichever one looks easier. To me, this one looks easier, right? But I just want to show you that both of them work. So now let's put both of these into function notation. And what we'll see is that even though they currently look different, once we put them into function notation, they will actually look the same. Okay, so let's start with the first one. So the first one was y is equal to negative 2 times x minus 5. So we don't have as much work to do on this one, right? Because we had y minus 0, so that just simplified to y. So, but let's distribute on the right-hand side so that we're able to actually directly compare it to the other one. So that's going to be negative 2x plus 10. And so that's going to be f of x is equal to negative 2x plus 10. So now we know that the y-intercept is 10. Okay, let's see what happens with this other one. So here we have y plus 2 is equal to negative 2 times x minus 6. So again, let's distribute on the right-hand side. So that will become plus 12. And then we can subtract 2 from both sides. So if we subtract 2 from both sides, we get y is equal to negative 2x plus 10, right? 12 minus 2 is 10. And so that is exactly the same as what we got using the other point. So truly you can use whichever point you want out of the two that are given. Okay, so I want to do one more example. This one is now going to be a word problem because I want you to see, I think point slope form can be especially useful for word problems because sometimes in a word problem, you're not given the information you need in order to write something in slope intercept form. Instead, you might just be given a couple of sort of different pieces of information, and you can always use those to come up with the equation. Okay, so suppose that there is a house cleaning service. So a house cleaning service charges $75 for 1 hour of cleaning, and it charges $185 for 3 hours of cleaning. So what we want to do here is we want to find a function that gives the cost of X hours of cleaning. So, this is a little different from the other word problems we've been working on in this section, because this doesn't tell us, most of the ones we've been working with, it's been like, oh, well, they charge this much per hour plus this initial fee or something like that. We're not given that information here. All we're given is the fact that we have $75 for 1 hour and $185 for 3 hours. So what we need to do here is we need to think of these as being 2 points on our graph. Because if you think of these as 2 points, then this problem will actually be exactly like this example here. Because we know now how to write an equation of a line that passes through 2 points, and then how to rewrite that in function notation. So here we have 2 points. So what are the points? Well, let's think about what is going to be our X and our Y coordinate. What's going to be like the input and the output for this function? So, eventually we're going to be trying to find a function that gives the cost for X hours of cleaning. And so that tells us that X is, or the input is the amount of time, right? And then what is the output going to be? The output is going to be the cost. And so that means that our first point is 175, right? Because that tells us that after 1 hour, it costs $75. And what is our second point? It's the point 185, because we know after 3 hours, it costs $185. So now we can go ahead and find the slope. So we're just going to proceed from here just like the last problem. So to find the slope, we take our 2 points and we do our change in y over our change in x. So we're going to do 185 minus 75 divided by 3 minus 1. So 185 minus 75 is equal to 110. 3 minus 1 is 2. And then 110 divided by 2 is 55. So that is our slope. And now we can choose either point we want. And in this case, I think, these points are pretty much equally simple, but let's maybe do the first point just because the numbers are a little smaller, we might as well. And so for our point here, we have an x coordinate of 1, y coordinate of 75. And so now we're ready to write our equation in point slope form. So we would say y minus our y coordinate, so y minus 75 is equal to the slope, so 55, times x minus our x coordinate, which is 1. And so this problem specifically asked us to write a function. So that means that we want to actually solve this equation for y and put it into function notation. So let's start by distributing the 55. And now we can add 75 to both sides. And so if we add 75 to negative 55, we're going to get 20. And so that means that our function is f of x is equal to 55x plus 20. Okay, one more question I just want to ask about this. Now that we have this in function notation, now we can interpret a little bit better what's going on with this fee, right? Like here, the information we were given was just kind of random. It was like, oh, well, if you do 1 hour, it costs this. If you do 3 hours, it costs that. We didn't really understand like where that cost was coming from. But now that we have this in function notation, we do. So what I want to answer here is basically what do the slope and the y-intercept tell us? What do those tell us about how this cost works? So remember that in general, when you have slope, that is a rate, right? It's per. Think of the word per when you hear when you're talking about slope. So what kind of rate would we be talking about here? Well, remember that we're trying to figure out the cost as we have, like, as how the cost changes for different hours of cleaning, right? And so that means that this slope tells us that the rate at which you are charged for this cleaning service is $55 per hour, right? So you're being charged $55 per hour for this cleaning service. And so what does the y-intercept tell us? Well, remember, y-intercept kind of tells you like the initial cost or the initial amount. And so that means that no matter what, no matter how many hours of cleaning you're purchasing, you're always going to pay this $20. So the $20, you can kind of think of it as an initial fee, right? Sometimes when you buy something, there's kind of two parts to what you're paying. Part of it is, okay, like everyone pays $20. And then the $55 per hour, that is on top of that initial fee. All right, so that is it for this video, and we will be moving on next to a completely new topic. So this will wrap up our discussion of lines and linear functions. I will see you all in the next video.